Clap. In this portion, we're going to learn on how to compute approximate or actual time problems. First, let us determine the terms. Now, let us put it in this way so that we can easily understand these terms. Now, in a worded problem, if the actual time was not stated, then we're going to automatically use the Bunker's rule or ordinary simple interest. But if the actual time was stated as exact simple interest, then we're going to use the 365 days. So, in short, the Bunker's rule or ordinary simple interest has 360 days. Otherwise, it is exact simple interest that has 365 days. Now, if we're going to compute the number of days between the loan date or investment date towards the maturity date of that loan or investment, we call it as the number of term. And that is about actual time that has 365 days and approximate time that has 360 days. When we say approximate time, all of the months has 30 days from January to December. But when we say actual time, each number of months depends on the real time. Example, for January, it has 31 days. In February, it depends on the year. If it is leap year, 29. If it's not, 28. Then so on and so forth. Take note that the Bunker's rule or ordinary simple interest is applied whenever a given problem does not specify the time factor to be used. Now, to understand this more, let us have an example. Example number 1. Find the actual and approximate time from May 1, 1983 to September 15 the same year. First, we're going to do the two columns because we're trying to solve for the actual and the approximate time. And it looks like this. Starts the original date of the month. The original month is May 1 and the maturity date is September 15. First, we're going to write here 15 to solve this because that is the maturity date. And here is as well 15. In solving for the actual time, let us have this strategy. Those months bolded in black has 31 days. And those months bolded in red has 30 days except for February. Now, this is only applicable for actual time. So, shall we start solving actual time, then the approximate time later? So, how are we going to put the number of days on the first row on May? First, we know that May has 31 days. So, we put it here as 31 minus 1 because that is the original loan date or investment date. Okay, we know 31 minus 1 is 30. June, okay, red, so that is 30. July, that is black, so 31. August is also black, 31. Then, in order to solve for the number of days in this term of note, just simply add it all. So we have 7, 3, 3, 3, 12, plus 1, that is 137 days. Now, how about approximate time? As I told you earlier, when we say approximate time, each month has 30 days. On the first column, the same process. So we're going to subtract 1 from 30. Why is it 30? Because it is approximate time. So the answer is 29. And all of the months has 30 days. Just simply add. This is 14, carry 1. This is 3, 6, 9, 12, 13. Therefore, from May 1, 1983 to September 15, 1983, the same year, when we are computing for the number of days for the actual time, it has 137 days. On the other hand, if we are going to solve for the number of days on the approximate time, it has 134 days. That is how we solve the approximate and the actual time for this example number 1.